Hello everyone, my name is Dr. Vaishali and the name of this channel is Tricks by Chemistry Group. Today, in continuation with class 10th, we'll talk about important questions and NCRT questions along with answers of chapter metals and non-metals. Let us talk about question number 1. From NCRT, it says, why is sodium kept immersed in kerosene oil? We know that sodium is very high reactive element. We know that it is highly reactive metal and it reacts vigorously with oxygen along with moisture. Means if it is placed in open air, it reacts vigorously with oxygen and moisture present in the air. So if it is left in open, it immediately catches fire. And to prevent this reaction, we need to store sodium under kerosene oil. Otherwise, it starts burning. Let's move to question number 2. Draw or write the electron dot structure for sodium, oxygen, and magnesium. When we talk about sodium, we know that its atomic number is 11. And 11 means when we write its electronic configuration, it goes 2, comma 8, comma 1. So in the last shell, we'll be having only one electron. So we'll place one dot along with the symbol of sodium, that is Na. So here you can see Na with one dot. Similarly, when we talk about oxygen, in oxygen, we'll place six dots around O symbol. And similarly, when we talk about magnesium, we'll place two valence electron around magnesium because its configuration is 2, comma 8, comma 2. So we'll place two electrons or two dots around the symbol of magnesium. Let's move to next question. It says, why do ionic compounds have high melting points? When we talk about ionic compounds, we know that they are formed by the complete transfer of electron, which results in formation of oppositely charged ions. And because of those oppositely charged ions, there is a strong electrostatic force of attraction. These forces are very strong as they are the electrostatic, the Coulombic force, and they require large amount of energy to break. So when we try to melt these substances, we need to make them apart, and thus we need to break those bonds, and thus they require very high temperature or large amount of energy, and thus they have high melting point. Next question is, why are alloys made? Give two examples. When we talk about alloys, we say that these are homogeneous mixture because they have the uniform composition. Now the thing is why they are made. They are always made to improve the properties of metals, such as we can increase the strength, we can increase the hardness, the resistance to corrosion. Like in the case of iron, when we mix it with chromium and nickel, will get stainless steel. Even mixing with small amount of carbon, we get steel. And sometimes increasing the appearance also. When we talk about brass, it is a mixture of copper plus zinc, which is stronger than copper. So to give it strength, we add zinc to it to make it more stronger. Similarly, when we talk about stainless steel, iron is mixed with chromium and nickel and it makes corrosion resistant. Now, there will be no stain or corrosion or rust on iron because now it has been changed into stainless steel. In this chapter, basically, you're supposed to talk about or consider about the metals and its nature, that they are highly electropositive. Electropositive means they have tendency to lose electron. They can form cations. They are good conductor of heat and electricity. Similarly, the non-metals, contrary to this, are electronegative. Electronegative means they have tendency to attract electrons. Once they gain electron, they form anions, and they are not good conductor of electricity with few exceptions. Metals react with oxygen to form basic oxides, whereas non-metals always form acidic oxides. Similarly, when we talk about ionic compounds, as we have studied just now, they have high melting and boiling points and they conduct electricity in molten or in aqueous state. And alloys are used or are made to improve the properties of metals. Thank you so much. God bless you all. Please like this video and share it with your friends and subscribe the channel.